Hello, good people. How are you? Welcome to Fiscal Sciences Revision for Term 3. So today I brought you a question paper from the Limpopo province. It is from the district of Mopani West. There's been a request that may we please do a question paper for grade 10 from Limpopo from the Mopani district. This is the question paper, people. Let's do it. Continue requesting as much material as you might want. Let's continue to shine light. Invite a friend to invite a friend to invite a friend. Let's help each other. Comment and actually get to leave your request. We will actually get to attend to everything. Thank you for requesting this question paper. So today we are going to use this question paper for our revision. It was for September 2023. It was written as a controlled test. So it was supposed to be written in 2 hours. So you can actually see that they say that it consisted of 100 marks. So the question paper had multiple choice questions, and then it had also structured questions. So we are going to start with our multiple choice questions as usual. So you know that for your multiple choice questions, you have got four options, which are either A, B, C, or D. So all you need to do is to choose one correct, accurate answer. There is always only one correct answer. Like they've mentioned here, that there is only one correct answer. So by all means, good people, let's try to actually get to eliminate our answers up until we are left with only one correct or else accurate answer. So let's get started. Question number 1.1 was saying that which one of the following physical quantities is a scalar quantity? So before we get to choose our options, we need to define what a scalar quantity is. So we know that a scalar quantity is a physical quantity that is fully defined by only mentioning its magnitude. So a physical quantity that you fully describe by mentioning its magnitude only, that is what we refer to as a scalar quantity. So now I want us to help each other to choose from the options that we have here to get to choose a scalar quantity. So A was saying a weight of 5 newtons. This is a vector quantity. Why? Because weight is that force of attraction towards the center of what? Of the earth. So there is direction there. We are always attracted towards the center of the gravity. That's why you would see that towards the center of the earth. That's why you would see that weight might actually be different here on earth and when we are on moon, because we have got direction towards where this force is attracting us to. So this one is a vector quantity. And then on B, a velocity of 10 meters east, they already gave you the magnitude as well as the direction. So this one is also a vector quantity. And then they said a current of 2 amps. This might be our options, because when you are actually describing current, you only mention its magnitude, which might be 2 amps or else 5 amps or else 10 amps. So according to our physical definition of a scalar quantity, our current will fall under what? A scalar quantity, because you only say 5 amps. And then a negative of 0.4 meters per square second. So you see that this is acceleration, and if you mention to say negative 0.4 meters per square second, it simply means that the object is actually decelerating, or else its rate of change of velocity is in the opposite direction. So there is already direction due to this sign as well as its magnitude. So our answer was actually going to be C. So let's go to 1.2. So you would see that a scalar quantity is just a quantity that you only mention its magnitude only, nothing else. So as long as you are able to mention its magnitude and you are done, that becomes a scalar quantity. Let's look at 1.2. 1.2 is saying three forces act simultaneously on an object as shown below. And then these are the three forces. We've got 5 newtons to the east, 2 newtons to the east, and then 3 newtons to the west. Then now they're saying the resultant net force acting on the object is. How do we calculate our resultant? So our resultant is equal to the net force, or else the sum of our three forces. So the first thing that we need to do there, we need to actually get to define the direction of our force, because force is a vector quantity. So it has got magnitude and direction. So we can see here we're given the magnitude, and the magnitude. So we now need to define the direction of each. So we will choose our east as what? As positive. So you can actually get to say that if this is our first force, this is our second force, and this is our third force, we're going to say positive 5 newtons plus positive 2 newtons plus a negative 3 newtons. And this was going to give us 7 newtons minus 3 newtons. So this was going to be equal to what? To 4 newtons. Since this is actually a positive, we know that our resultant force was just going to be 4 newtons what? East, because we choose a positive direction to be what? To be towards the east. So our answer was going to be D. And then I know that at some point in time, our memorandums, they've got typing errors and then some other errors. You might find different answers there. All you need to do is to cross-check with your notes as well as your textbooks. Sometimes our memorandums, they're just written by people. They might do what we call typing errors. Sometimes it's just calculation error. So just get to know that whatsoever answer that we get to determine here, it's not because we are trying to say that those people who wrote the memorandum, they were wrong. Sometimes they make mistakes. So you need to cross-check with what you know with your notes as well as your textbooks. So when you are revising, please cross-check your memorandums with your notes. Then it becomes easier there. So let's do question number 1.3. An object of mass m is released from rest from the top of a frictionless inclined plane AB as shown below. Now they are saying which one of the following is correct regarding the total mechanical energy of the object. So we know that total mechanical energy, what we refer to as total mechanical energy, there is a law that governs what we refer to as total mechanical energy. That law says that our total mechanical energy is always conserved as long as there is no dissipative force, or else as long as our system is closed. So here they say that this object is released from rest from the top of a frictionless inclined plane. So when they say there is no friction there, they are simply telling us that there are no dissipative forces. There are no dissipative forces. Once these forces are absent, we actually get to assume that the system is what? The system is closed. Once our system is closed, we know that our total mechanical energy at a point 1 would also be equal to the total mechanical energy at a point 2 within the system. So it means that the total mechanical energy at A, the total mechanical energy at A will be equal to the total mechanical energy at B, because we are saying that our system is what? Is closed. So our total mechanical energy is conserved. And we know that how do we calculate our total mechanical energy? We know that total mechanical energy is equals to potential energy plus our kinetic energy. So we can actually get to come here and say potential energy plus kinetic energy at point A is equal to potential energy plus kinetic energy at point B. That is what it means, because we are saying that this system is closed. We are assuming that, or else we are neglecting our dissipative forces. Like for example, when they say frictionless inclined plane. So this mass is just going to roll with no opposing force there. So the total mechanical energy that it was having at point A should be equal to the total mechanical energy that it will be having at point B. So now let's check our options and let's get to see which one was going to be correct. This one is saying greater than, so this one is wrong. And this one is saying less than, so this one is wrong. And then this one is saying equal to. Now let's check. They are saying potential energy plus kinetic energy at point A is equal to potential energy plus kinetic energy at point B. And this is actually correct. This one is saying equal to a negative. No, this one is actually what? Wrong. They are equal in magnitude as well as the sign. Because we are saying that here we are having a positive total mechanical energy. Here we are supposed to also have a what? A positive total mechanical energy. So this one is wrong. So our answer was supposed to be equal to what? To C. Now let's actually get to go to what? To 1.4. So just to actually get to clarify about that negative, we know that our energy is a scalar quantity. So we know that energy does not have what? Direction. Energy is a scalar quantity. So it has no what? It has no direction. So you cannot say here we have got a negative and then there we have got a positive. No, we actually get to say, if we actually get to say it's negative, here it has also to be what? To be negative. What it will simply mean is that at some point in time, maybe when you say negative, it means that we have received energy. So if we received energy here, we are also going to receive energy there. So let's go to 1.4. Now, 1.4 is saying a car is traveling at a speed of 30 meters per second on a straight road. What would be the speed of the car in kilometers per hour? So we need to actually get to convert 30 meters per second into what? Kilometers per hour. So when we say 30 meters per second like that, when we are now converting, we get to say how many seconds are there in an hour? There are 3,000 seconds in 1 hour. And then we get to come and say, how many meters are there in a kilometer? They are 1,000 meters in 1 kilometer. Because we want our answer to be in kilometers per hour. So we want our kilometers to be on top. So we know that there are 1,000 meters in 1 kilometer. So we will remain with our, with our kilometers there. These meters will cancel with those meters. And then we also want our hours to be on the denominator. So we are going to remain with our hours below there, and then our seconds are going to cancel with our seconds. When we do this, what is the final answer that we are going to get? So you can see that this is more like just saying 30 times. You can actually get to say, if I say 3,600 divided by 1,000, it will just be 3.6 kilometers per hour. So if I say 30 times 3.6 kilometers per hour, what is the answer that I'm going to get? So I was going to get what? 108 kilometers per hour. So I'm looking for the answer that says 108 kilometers per hour, which is what? Which is C. Now let's go to question number 1.5. So you can see that question number 1.5 is saying a car is traveling at a constant velocity along a straight line, or else along a straight road. It then slows down uniformly. Which one of the velocity time graphs below best represents the motion of the car? Let me read that again. A car is traveling at a constant velocity along a straight road. So the velocity is constant along a straight road. It then slows down uniformly. Which one of the velocity time graph below best represents the motion of the car? So you can see that A actually represents uniform increase in the what? In the velocity time graph. So this is uniform increase of what? Of our velocity. This is constant acceleration. So this is out. And then you can see that B represents constant velocity for a certain time. Yes, we need constant velocity because they told that a car is traveling at a constant velocity along a straight road and then it slows down uniformly. But here it is now increasing its velocity. So here it is accelerating instead of what? Slowing down. So this one is also out. We go to this one, we have constant velocity up until to a certain time, yes, and then now the car, its velocity is now what? It's now decreasing. So this actually shows that the velocity or else the car, it's now what? Slowing down. So I'm sure this is the graph that we are looking for. So our answer was just going to be equal what? It was just going to be equal to C. Because if you come to D here, it is just constant throughout. So this is out. So our answer was going to be C. Now let's go to the following questions. Now we have got 1.6. Let's hear what 1.6 is saying. 1.6 says they are dash atoms of hydrogen in 2 moles of what? Of ammonia. How many atoms are there of what? Of hydrogen in 2 moles of ammonia. So what we need to do is to look at the atomic ratio there. So you can see that it's 1:3, meaning to say that within each ammonia, there are 3 atoms of what? Of hydrogen. So now they are now asking us, in terms of 2 moles of ammonia, we know that 2 moles is equivalent to what? To 2 times 6.022 times 10 to the power 23 atoms. And then now they're telling us that in ammonia, there are 3, in terms of its ratio, it's 3 atoms of what? Of hydrogen. So when you want to calculate the total number of atoms of hydrogen that are in ammonia, you now come to say these 3, which represents the ratio of the what? Of the number of atoms in ammonia of hydrogen. And then you get to say 3 atoms of what? Of hydrogen times 2 moles of what? Of ammonia. And 2 moles represents what? It represents 6.022 times 10 to the power 23. So if you do this, you are going to get an answer which says what? 3.61 times 10 to the power 24. So our answer was just supposed to be equal to what? To C there. Because you would say 3 times 2, it would be 6. And then if you say 6 times 6.022, you are going to get 3.61 times 10 to the power 24. Now let's do question number 1.7. So question number 1.7 was saying, which one of the following molecular mass represents hydrogen chloride? So how do you represent hydrogen chloride in terms of its molecular formula? You have got H1 and then Cl, because we know that H, it is H plus and Cl, it's minus. So when you are actually getting to combine that as a compound, it becomes HCl. Now we now have the molecular formula. We now need to determine its molecular mass. So this becomes 1 plus 35.5, because the atomic mass of chlorine is 35.5. So the answer there was just supposed to be equal to what? To 36.5, because if you say 1 plus 35.5, you are going to get what? 36.5. So our answer was going to be C. Let's go to 1.8. Let's go to 1.8. So you would see that 1.8 was saying that study the equation below. Let me just rub the one that is on top so that we can see our question clearly. They are now saying study the equation below, which is hydrogen molecule plus oxygen molecule to actually get to what? To form 2 water molecules. So now they are saying which one of the statement below is correct. Two molecules of hydrogen gas react with one atom of oxygen gas to form. So for us to determine which statement is correct, we need to first balance this equation. We know that chemical reactions or else chemical equations which are representing chemical reactions, they need to be balanced so that we can be able to determine whatsoever relationship that we have there. So you can see that this side I've got two hydrogen atoms, but this side I've got four hydrogen atoms. This side I've got two, so this one I've got two, and then this one I've got two. But this side for hydrogen I've got four, and then for oxygen I've got two. So something has to be done this side. So I need to multiply by 2 here so that there can be 4 for hydrogen. So that here I can actually have what? So that this side I can actually have 4. So we are saying that the balanced equation there was going to be two hydrogen molecules reacting with one oxygen molecule to form what? To actually form two water molecules. So we are looking for information which describes our equation in terms of this. So you would see that two molecules of hydrogen gas, yes, they react with one atom. They are not reacting with one atom of oxygen gas. There are two atoms here. So this is actually out. So we actually get to say there is one molecule of oxygen gas. And within one molecule, how many atoms do I have of oxygen? You get to see it. So this one is actually wrong. And then here we are saying two molecules of hydrogen gas react with one mole of oxygen gas to form 2 moles of water. Now let's actually leave this one. I'll come and explain. 4 atoms of hydrogen gas react with 2 molecules of oxygen. So I've got 4 atoms of what? Hydrogen gas. These are 4 atoms of hydrogen gas reacting with 2 molecules of what? Of oxygen gas to form 2 moles of water vapor. And then now I'm saying that this one is actually what? We are saying 4 atoms of hydrogen gas. This is correct. 2 molecules of oxygen. This is correct. And then 2 moles of water. This is correct because they are, in terms of mole ratio, they are 2. In terms of molecules, we get to say what? Do I have 2 molecules of oxygen? This is wrong. I don't have 2 molecules of oxygen there. I only have got 1 molecule of oxygen. So that one is wrong. So we get to say that this one is also wrong. So the answer there, which was more accurate, is supposed to be B. Let's go to D. 4 grams of hydrogen gas react with 16 grams of oxygen gas to form 18 grams of water. Now, if we actually get to say 8 grams of hydrogen gas react with, we now need to determine our mass in terms of what? Whatsoever that is given. The information that is given there, it did not mention anything to do with the mass of what? Of hydrogen. Yes, we know the molecular mass of hydrogen, but in terms of the number of molecules that are reacting, that cannot actually get to translate to what? To 4 grams of what? Of hydrogen. So we can see that for 1.8, our answer was just supposed to be B, where we have got 2 moles of hydrogen gas react with 1 mole of oxygen gas to form 2 moles of water vapor. So now you are saying that you are relating this in terms of its mole ratio. In terms of its mole ratio, you are given 2 moles of hydrogen gas, 1 mole of oxygen gas, and then 2 moles of water, according to the balanced equation. So B was more accurate there, other than everything else. So our answer was going to be B. Now let's go to the following questions. So I've got 1.9 and 1.10. 1.9, it's saying the Avogadro's number is equal to the number of. The Avogadro's number, we know that our Avogadro's number, which is just Na, it's equal to 6.022 times 10 to the power 23. Now, which one of these is equivalent to this number? That is what they are asking. So in terms of atoms, in 1 mole of CO, they are saying that the Avogadro's number is equal to 6.022 times 10 to the power 23 atoms in 1 mole of carbon monoxide. This is wrong because we have got we have got 1 atom of carbon, and then we have got 1 atom of what? Of oxygen. So within this compound, there are 2 atoms. But however, though, we have got 1 mole of carbon monoxide. So the total number of atoms was supposed to be equal to what? To 2 times 6.022 times 10 to the power 23. So this becomes wrong. And then now let's go to the following. Here, good people, have got 2 atoms times the number of atoms that are represented by 1 mole. There will be 2 times this, so they are not equivalent. Now let's go to 6.022 times 10 to the power 3 atoms in 1 mole of bromine. We can actually get to see here we have got 2 atoms, 1 atom there, 1 atom there. Times 2, they are going to be more than. So this one is actually wrong. And then in terms of molecules, in 1 mole of silver, silver is an element. This one, it's an element. It's actually a metal. It is not, we have no silver molecules. So this becomes wrong by just saying the notation of molecules in silver, they are wrong. This one is an element, and in an element, there are no molecules. Now, we go to molecules in 1 mole of nitrogen. Yes, this one is a nitrogen gas. And within nitrogen gas, there are how many molecules? They are 1 times 6.022 times 10 to the power 23. So we have got 6.022 times 10 to the power 23 molecules in 1 mole of nitrogen. Because we know that 1 mole simply represents this number times 10 to the power 23 entities. And these entities, they can either be atoms, or else they can be what? They can be molecules, or else they can just be single particles. So we know that this number represents either molecules or atoms. So in terms of molecules, in 1 mole of nitrogen, we have got 6.022 times 10 to the power 23 molecules. So our answer was equal to D. This represents, or else this is equal to the Avogadro's number. So now just allow me to wrap these ones. So our answer there was going to be equal to what? To D. (1.10) The percentage of hydrogen in C2H4 is the percentage of hydrogen in that compound. So this is actually what? Ethene. And then in ethene, which is C2H4, how much is our hydrogen in terms of percentage? So we simply look at the atomic mass of carbon. Atomic mass of carbon is 12. Atomic mass of hydrogen, it's 1. And how many atoms of carbon do we have here? We have got 2. So this one is equal to 24. And then how many atoms of hydrogen do we have there? We have got 4. This one is equal to what? 4. So now we get to say that the total mass of hydrogen that is within this compound, it's equal to 4 grams. The total mass of carbon in this compound is equal to 24 grams. What is the total molecular mass of this compound? The total molecular mass is equal to 24 grams plus 4 grams. This is equal to 28 grams. Now, in terms of percentage composition, how much is our hydrogen? Our hydrogen in terms of, so you would say percent of what? Of hydrogen. It is going to be equal to 4 grams divided by 28 grams times 100. And what is that value? So if you say 4 divided by 28 times 100, you are going to get what? you are going to get a value that is equal to 14.29% after rounding off. So our answer there is supposed to be equal to D. That is our answer for 1.10. So you are looking for the percent composition in terms of atomic mass within this molecular compound. So let's go to the following questions. Now we have got question number 2. Now we have started our section B, which is structured questions. Now on our structured questions, question number 2 is saying the velocity versus time graph for a racing car moving eastward is shown below. So this car, they are saying that it is going to what? Towards the east. So initially its velocity, it's 30 meters per second, and then its velocity increases uniformly to 40 meters per second, and then it was after 5 seconds, and then it moves with that constant velocity for around what, 20 minus 5, for around 15 seconds. So for 15 seconds the velocity is constant, and then it starts to actually decelerate or else to slow down up until its velocity is 0 there, and then it also continue to decelerate uniformly from C to E up until its velocity is what? It's a negative 20. So we can see that this time around the car is now moving in an opposite direction. So here it's now moving towards the what? The west. Now let's hear the questions. Write down the initial velocity of the car. The initial velocity of the car is this one, which is 30 meters per second. So our initial velocity is what? 30 meters per second. Or else maybe you would have just came and written it in notation of saying we know that V initial would be equal to what? 30 meters per second. It was just the same thing because they just said write down the initial velocity. Now write down the speed of the car at time t is equals to 10 seconds. So we need to go to time t is equals to 10 seconds and look for that instant velocity or instantaneous velocity. So time is equals to 10 seconds. It's in between 5 and 10. So somewhere in the middle there. And then our instantaneous velocity is actually equivalent to 40 meters per second, because from B to C the car is moving at a constant velocity. The velocity does not change there. The velocity is not changing along that path. So here our velocity there, our velocity at time is equal to 10 seconds, was going to be equal to 40 meters per second. That was our velocity. And then now they are saying describe the motion of the car for the section labeled CD. So we want to describe the motion of the car for the section labeled CD. The section labeled CD is this one. You can see that the car is moving at a what? It's slowing down at a uniform acceleration. So we are actually going to say that from C to D, the car, let me just get to say this one is 2.3. From C to D, the car slows down uniformly from a velocity which is equal to 40 meters per second to 0 meters per second. So at some point in time at D there, the car would be at rest. But however, you can see that it continues to slow down up until it is now at a negative. So it means that it comes to rest and then it turns around and then it starts what? Moving in the opposite direction. So that is how you would have just described that motion. So now let's go and see the following questions, or else maybe let me just get to write it down below 2.3 there. So let me rub whatsoever that I wrote on top so that I can write it where you can actually get to see where it corresponds to. So as we are doing questions, someone would actually get to want to see the answer close there. So we are saying that the car it slows down uniformly from a velocity which is equal to what? 40 meters per second to 0 meters per second. To 0 meters per second. That is how you would have just described that motion. Now let's look at 2.4. Support the answer to question 2.3 above by calculating the acceleration for CD. Now we want to calculate the acceleration for CD. CD is from there to there. How do we calculate our acceleration given a velocity time graph? We know that this is equal to the what? To the gradient. So here they'd say that describe the motion of the car for the section labeled CD. And then here they're saying support the answer to question 2.3 above by calculating the acceleration for the what? For the section CD. So the acceleration, we find it by calculating the gradient. How do you find the gradient? You just simply say y2 minus y1 over x2 minus x1. So you take the y value at point 2. So here this is our point 2, this is our point 1. The y value here, so our acceleration here was going to be equal to the y value here, it's 0. So it will be 0 minus the y value here, it's 40. So it will be 40 divided by the x value here, it's 25. And then this one was going to be 25 minus the x value here, it's actually 20. So it was going to be 20 and then equal to, this was going to be a negative 40 divided by 5. So this was going to be equal to a negative 8 meters per square second. So we say that the car is slowing down uniformly. So it is slowing down at this acceleration. So this negative supports our answer in terms of saying that it is accelerating in the negative direction. So it is decelerating, that is slowing down. So that is how you would have just done it. So you were just supposed to come here and calculate your acceleration. And you were supposed to know how you calculate acceleration. Acceleration given a velocity time graph, you calculate it using the gradient between those 2 points. And that is what we have done here. Let's go to 2.5. 2.5 is saying, without any calculation, compare the magnitude of the acceleration of the car in part D to E with that of part C to D of the journey. Write only greater than, less than, or equal to. So you would see that from C to D, let me just wrap that. From C to D, the gradient here, you can see that it is the same. Do you get to see that the gradient here is the same? We have got what? Our same gradient from C to D. So for the part D to E, the acceleration is equal to the part C to D because of the same gradient. So you would have just came here and said for part 2.5, they said that give a reason for your answer. They said without any calculation, compare the magnitude of the acceleration. So you would say that it is what? Equal to. Equal to. And then you would say because the gradient is the same. Because the gradient is the same. So we have got the same gradient. So the acceleration was just going to be equal. Now they're saying determine the total displacement of the motion of the car. How do you find displacement under a velocity time graph? Displacement, we know that displacement under a velocity time graph is just equal to the area under that graph. Under a velocity versus time graph is given by the area under that graph. It's given by the area under the graph. So what we need to do here, if we are going to calculate the total displacement, we need to calculate the total area under the graph of that velocity time graph. So how are we going to calculate the area under this velocity time graph? We're just going to actually get to divide our graph into different parts so that we can name the shapes of those parts. Once we name those shapes, we will be able to actually get to what? To calculate the total displacement. So we can actually get to use this first part here, where it's starting from here to there. So you can see this one is a trapezium. So this one is a what? It's a trapezium. I will say trap for trapezium. And then from here, so this is area A. And then our area B, it's actually going to be this part up until we are on that part. So you can see this one is a what? It's actually a rectangle. And then we can see that the last, this part C, which is making this shape, it is actually a what? A triangle. So here we have got a what? We have got a triangle. And then here we actually have got a what? We also have a triangle, which is part D. We have got a what? A triangle as well. So now when you're now calculating the total displacement, let me just get to use this space that I have here so that you can be able to relate. You just come and say your total displacement is equal to area of, let's get to say trapezium, area of trapezium plus area of what? Our rectangle. And then plus area of the what? Plus area of that triangle plus area of the triangle, which is triangle C, plus the triangle D. And then you would come and also get to add the triangle D there. So you would also get to say plus triangle D. That is the total displacement. With that now, we now need to fill in our information. So now the area of a trapezium, we all know that area of a trapezium is given by base 1 plus base 2 divided by 2. And then we multiply by the height. And then area of a rectangle, its length times its breadth, plus area of a rectangle, of a triangle, it's half of its base times height. And then another half of that base times height. So we need to determine base 1 and base 2. So the first base would be from here to there. That becomes our what? Our base 1. And then our base 2 would be from here to there. So our base 1 is actually 40. So you are just going to say 40 plus our base 2 it's 70. It's 30, sorry. And then over 2. I'm actually now calculating this. Now height, the height is from here to there, which is just 5. So we multiply by 5 there. And then we come to add our length times breadth. Length, it's 20 minus 5. It becomes 15. It becomes 15 there. Times our breadth, which is from here to there. It becomes 40. It would have been maybe 40 times 15 is just still the same thing. Plus half of our base here, it's 25 minus 20, which is just 5. So this one becomes 5 times our height, it's 40, plus half our base here, it's from here to there, it's 27.5 minus 25, that becomes 2.5. Times this height from 0 to negative 20 is just negative 20. So we actually get to take this negative because we are calculating displacement. Displacement is both magnitude and direction. So we need to take that negative 20. We need that negative as well when we are mentioning here. So you would say times negative 20. So that your displacement, it's either going to be a positive or a negative. Now, if it is a positive, we said it is moving eastward initially, so our eastward direction is positive. If it becomes a negative, you know that it is going to be unto the what? Unto the west. So let's try to calculate our this total displacement here. So if you say 40 plus 30, it's 70 divided by 2, 35 times 5, and then you get to say plus 15 times 40 plus half of that plus that. You were supposed to get an answer of, let me just get to use my calculator there. So if I actually get to use my calculator, the answer that you were supposed to get there at the end of the day, you were supposed to get a positive, you were supposed to get a positive 850 meters. So if it is a positive 850 meters, what does it mean? It means that our total displacement is equal to 850 to the east. So it is 850 meters towards the east. That is total displacement. That is how you would have calculated your total displacement. Now, I'm sure that was the final question of question number 2. Yes, 2.6 to say determine the total displacement of the motion of the car. It was just 850 meters east. Now let's go to the next question. So question number 3 was saying a taxi is traveling at a speed of 25 meters per second when a traffic light 40 meters ahead changes to red. And then they say define the term acceleration. What is acceleration, guys? Acceleration is simply the rate of change of velocity. So you would say acceleration is the rate of change of velocity. It's simply the rate of change of what? Of velocity. Or else you would say change of velocity per unit time. Change of velocity per unit time. So change of velocity per unit time simply means a rate where you would have delta V over what? Delta T. So this velocity is changing per unit time. So that is what acceleration simply means. Now let's go to the following question. So allow me to just get to move our question upward so that we can get to see the following questions. Now they are saying the driver takes 1 second to react, which is the reaction time, before he slams on the brakes. The taxi then stops within 2 seconds. Is the velocity and the acceleration of the braking taxi in the same direction as it moves towards the traffic light? No, they are not in the same direction. Why? Because at the end of the day, the final velocity is going to be 0, but acceleration is not going to be what? 0. So acceleration is going to be on the negative. So this negative shows you that acceleration would be what? In the opposite direction. What am I trying to say there? I'm saying that when the car stops, it simply means that the car is actually slowed down. So slowing down is related to what? To deceleration. So if we were here in terms of the velocity time graph, and then you end up here, and this one is actually 0 meters per second, it simply means that this acceleration is a negative. The slope is a negative. So the direction of the acceleration is opposite to the direction of the what? Of the velocity. So you would have just came here and said, no, they are not. So that was the answer there. And the reasoning is that the acceleration is in the opposite direction as the what? As the change in velocity. So the change in velocity, sorry, is actually in the opposite direction to the what? To the direction of the velocity. So we can actually come to say, they said, give a reason for the answer to question 3.2. You'd say that here you'd come and say your velocity is towards the right, ne? You would come and say your velocity is toward the right because that is where the car is moving. The car is moving towards the right, towards the right. And your acceleration is in the opposite direction. Your velocity here is towards the right. Let me just get to find some way need to write this answer. So I would clear this out. So we are saying that your velocity is toward the right whilst the acceleration is in the opposite direction. So you would have said velocity is to the right, comma, while acceleration is in the is towards the left, or else in the negative direction, is in the negative or else opposite direction. So what you're simply explaining is my velocity is towards the right. That is where my velocity is going. But the change in velocity, it's actually slowing down. So the change is towards the opposite direction. Because at the end of the day, I would have a velocity of 0 meters per second from a velocity of what? Of, let's say, 30 meters per second. They say the velocity there is 25 meters per second initially. So if the velocity initially was a positive 25 meters per second, and then it comes to 0 meters per second, it simply means that the change was a negative here. There was a negative what? There was a negative change. So that at the end of the day, we have got 0. Because you know that for you to find a 0 from a positive, you need to subtract something. So you need something that is negative there. So at the end of the day, we are saying that our change of velocity is in the opposite direction. So velocity is towards the right, whilst acceleration is in the opposite direction. That is what you would have said there. Now they are saying, calculate the distance the taxi travels during the reaction time. What was the reaction time? They say that the driver takes 1 second to react, and then before he slams on the brakes. So here, my total time taken is what? 1 second. My initial velocity there is what? 25 meters per second. And then for me to find the what? I need to find the what? The total distance that was traveled. So delta x can be actually equal to what? VIT, or else VI delta t plus half of my acceleration delta t squared. And then I would come here. So here I'm doing what? I'm doing question number 3.4. So this is 3.4. That is how you would have just done it. Because you've got your initial velocity and your time taken. You can use the equations of motion. So now I can see that here I have no acceleration. And then I can actually get to go to say that the other one says what? The other one says delta x is equals to v final plus v initial all over what? 2. But now I'm told that within this 1 second, there is something that was mentioned. Maybe something that we have missed here. They say that a taxi is traveling at a speed of 25 meters per second when a traffic light 40 meters ahead changes to red. And then they are saying the driver takes 1 second to react. So he will move with this constant speed whilst he is trying to actually think of his reaction. So now we are actually getting to say that the acceleration there would be a 0. So here I would have just used the acceleration of 0. You would see that here you would use what? 25 and then times 1 plus this one, because of the 0 acceleration, to be 0. So the distance moved would be 25 meters per second. But however, it has to be the same with this, which says VF plus VI over 2, which is my average velocity, times the total time taken. So my average velocity, since it's 25 plus 25, I'm moving at the same speed there I would add those and then divide by 2 and then multiply by, I'm multiplying by what here? I'm actually multiplying by 1. So here I'm actually multiplying by 1, not 2, sorry. So if you multiply by 1, if you say 25 plus 25, it will be 50. 50 divided by 2, it will still give you 25. So the distance moved there was just 25 meters, not meters per second. So answering 3.4, you were just going to use those equations of motion. And then that was going to be your answer. So guys, pardon me, sometimes I just get to use the available space there. I actually want to show you how you do these things. I'm not here to give you answers. I'm here for us to help each other to see how we actually get to solve this. So try by all means to follow what we'll be doing. Don't wait to say, I want to see the final answer, because we have got memorandums for that. They can actually give you what final answers. But here we are here to help each other see how that memorandum would have done it, or else how we're supposed to have done it. So I say that you can either use this equation or else use the one for average velocity, where you know that average velocity at some point in time, when you get to say that VF, let me get to say that my average velocity, you know that average velocity would be given by final velocity plus initial velocity over 2. That is my average velocity. And I know that at some point in time, this average velocity can be given by change in the total displacement moved over the total time. So if I want to find this, I'll cross multiply, so that delta x will just simply be equal to what? Vf plus V initial over 2. If I know the average velocity, I'll just multiply by the average velocity times the total time taken. So here we were given 25 plus 25 all over 2, and then we multiply by 1 second. And this was going to give you 25 meters, which is the same as using this first equation. So that is how you calculate the distance the text travels during the reaction time. So during the reaction time, V is what? It's constant. The velocity or the speed that the driver would be moving at would be constant, because he hasn't reacted yet to say, am I applying the brakes or else am I speeding up? Now, after that, let's go to the following question. So the following question was saying that, will the text stop at the traffic light? Show all calculations. Now we want to determine if, using this information that we are given here, this car is going to be able to stop here, which is 40 meters away from this distance, or else it is not going to be able to stop here. It will stop maybe after the traffic light, using this time, the time of reaction, and then the time it took after he slammed the what, the brakes to actually get to come to rest. So I would actually get to say that, let's see how we would have done it. I would try to create space, ample space, maybe. Let's use this side so that I can be taking information from this side. So now we are saying that uh, initially, let's get to say for the time of what? For the time taken of 1 second of reaction time, the driver moved 25 meters. And then what about on that 2 seconds after he slammed the brakes? What was the distance that he moved? So you would see that you can actually use Vf is equals to Vi plus A delta T to calculate your final what? Your final velocity. If you actually get to know your final velocity, actually you know it is going to be 0. So you can calculate your what? Your acceleration. So that at some point in time you can use delta x is equals to Vi delta t plus half of the acceleration delta t squared. So this acceleration, you can get it from this equation. So using this first equation, let's actually get to use it. We have got 0 meters per second, because finally he comes to rest. So his final velocity is going to be 0 during these 2 seconds. And then his initial velocity came from 25 meters per second. So it will be 25 plus, I'm using this equation to calculate my acceleration, plus my acceleration that I'm looking for. And then you took 2 seconds. So you would actually get to see that this would be, I would bring this one this side, and this one would be a negative 25 being equal to A times 2. So for me to find A, it would be divided by 2 divided by 2. So my A would be equal to negative 12.5 meters per square second. So that was the acceleration that this driver was moving at. So you can see that the acceleration is negative. So he is slowing down. Now let's actually get to see what would be the distance if I input this acceleration here. We want to determine the distance, the braking distance. So the braking distance there during my 2 seconds would be equal to my initial velocity is 25 meters per second times my time taken 2 plus half of my acceleration, which is negative 12.5, and then 2 squared. So this was going to give me what? If I say this one was going to give me 50, and then if I have here, I've got 4. 4 divided by 2, I would have 2. 2 times 12.5, it would be 25. And then if I do my calculations, I was supposed to have 25 meters. So his braking distance was 25 meters. But he had already moved 25 meters before. So we are actually going to say that from the time that he saw the robot up until he applied his brake, up until his car came to rest, the total distance that was moved. So allow me to just get to move this on top. So we would say that the total distance that he moved, delta x total, is equal to the 25 meters moved in 1 second plus another 25 meters moved in 2 seconds. So this total distance that was moved is equal to 50 meters. So this total distance tells us that the driver actually came to rest, or else the car was going to stop after 50 meters from here. So 50 meters from here is actually beyond this robot, or else this traffic light, because from here to there it's 40 meters, but up until where the driver actually came to rest, or else where his car managed to stop, it's 50 meters. So the driver is not going to be able to stop on this traffic light or else before, but instead is going to go beyond this traffic light. So let's hear what the question was saying, and let's see if we have answered the question. Will the taxi stop at the traffic light? Show all calculations. The taxi is not going to stop at the traffic light. Why? Because this 50 meters is more than 40 meters, which is the distance to the traffic light. So you would have come and said 50 meters, which is your what? Your braking distance, your total braking distance is greater than 40 meters, which is the distance to what? Distance to this traffic light. Distance to the traffic light. So you can see that definitely by saying this, you are simply saying that the taxi is not going to be able to stop at the traffic light. So that was actually how you would have calculated it. So let me just do a recap of this, because I know at some point in time, by saying a lot of things, moving up and down my mouse, shifting my page, someone would actually get to miss my point. So I would want to actually get to repeat what I've just said and then write it in a neat way so that you can actually get to catch up if we lost you somewhere. Because I usually have that with other students that I get to meet face to face, that at the end of the day, after you are done talking, you think that maybe you are on the same page, but you get to see that you are actually not together. So we are saying that our question was what? For question 3.5, which is saying will the text stop at the traffic light? Show all calculations. This is what you should have just came and did here. You were just supposed to do this, to say 3.5. If I were you, I would come and say distance moved in 1 second. That distance is equal to what? 25 meters. We calculated that distance already. We calculated that distance. So if this distance moved in 1 second is equals to 25 meters, that is the distance that the taxi driver actually moved in what? In 1 second. What about the distance moved in 2 seconds? Distance moved in 2 seconds. It is equal to what? That is where we say our initial velocity was equal to 25 meters per second. Our final velocity equal to 0 meters per second because it came to rest. And then our time that it took to come to rest was 2 seconds. So the first thing to do there, you can calculate your acceleration. Because we want to find the distance we can find it by vi delta t plus half acceleration delta t squared, or you can use vf squared is equals to vi squared plus 2a delta x. We have this, we have this, we have that, but we do not have what? Our acceleration. We are looking for this, in fact. So it will be easier once we find our acceleration to choose which equation to use. So we are looking for our acceleration. So our acceleration, we are going to use v final is equals to v initial plus the acceleration times the change in time. So if I feed my information here, I would have 0 equal to 25 plus acceleration times 2. And then I would have a negative 25 being equal to, I'll bring this that side, and then a times 2. If I divide throughout by 2, my acceleration would be equal to negative 12.5. So I've determined my acceleration there. So I would come and say delta x, which is the distance moved in 2 seconds, would be equal to my velocity here, it's 25, times my time, it's 2, plus my acceleration there, it's a negative 12.5. And then I multiply by the time, which is 2 seconds, divided by 2, because it's a half AT. And then I say that the distance that we are going to find here was equal to 25 meters. If you punch in your calculator, you are going to get this distance. After that, we have now determined the distance that was moved in 1 second and then in 2 seconds. So the total distance that was moved by this car before it came to rest, we say that total displacement that the car moved before it came to rest was equal to 25 meters, which was moved in 1 second, plus 25 meters that was moved in 2 seconds, which is equal to what? 50 meters. And we can see that 50 meters is greater than 40 meters, which is the distance in between our traffic light and our car. Once we find the distance more than this, it simply means that the taxi driver is not going to be able to stop here. That is what we said. So that is what we are just supposed to do using calculations. So after your calculations, we are just supposed to say that the taxi driver will not be able to stop at the traffic light. So you would just come and say, therefore, you would just come here and say, therefore, we know that this represents, therefore, the taxi driver, or else the taxi will not be able to stop at the traffic light. At the traffic light. So that taxi was not going to be able to stop at the traffic light because the distance, the braking distance that it requires is greater than the distance in between the car and the traffic light. Now let's hear the following questions. 3.6 is saying draw a position versus time graph for the motion of the what? Of the text. Draw a position versus time graph for the motion of the text. For the motion of the text. So for the motion of the text, you were just supposed to draw a graph that will look like this. If you are drawing position time graph, some point in time, that will be your position, and then that will be your time. So going this side, it will be time in seconds. Going that side, it will be position, which you might represent in x in meters. And then now you would see that maybe that car, we would actually get to say that it starts at a distance x that we do not know. Or else you can say that it starts at 0. To determine, you only want to draw the graph from where it started to represent it to be at 0, 0. So you would start it at 0, 0. And then from 0, 0, for 1 second, it moves at a what? At a uniform velocity. So you need to draw a constant line that proves, or else that show a constant gradient. So this would be for what? For 1 second. And then for the first second, we say that our car moves for what? For 25 meters. And then after 25 meters, it starts to decelerate. So the gradient is decreasing. So a gradient can decrease like this up until the gradient is 0. So that is what you are just supposed to actually get to come and do here. That the gradient is decreasing up until the gradient is 0 here. Once you are now at a constant line of your what? Of your displacement, it simply means that our displacement is constant and there is no change in what? Displacement, therefore the velocity will be 0. So this was after another 25 meters. So after another 25 meters, it makes what? It actually makes 50 there. So there you are just supposed to say 50 meters. So this was the graph that you were supposed to show, and then you show that this was after how many seconds? 1 second plus 2, it actually comes to 3 seconds, because that was the total motion of the what? Of that car. So this was the position time graph, where you need to actually get to say position versus time. So they give you marks for knowing how to represent position in the y-axis and then time in the x-axis. And then they will give you marks for these correct plots where you have got a constant line which shows this constant gradient, which is to say uniform gradient, uniform velocity, and then this decreasing gradient up until 0 to show that your car is decreasing in gradient, decreasing in velocity, it is slowing down. So now let's go to question number 4. So you can see that question number 4 was saying an impatient businessman paces up and down while making a business call on his cell phone. So the businessman is pacing up and down. They are saying this guy is impatient. So he paces up and down because at some point in time, maybe he hasn't heard what he needs to hear yet. Now they are saying he starts at his desk and walks 5 meters east. So from his desk, he walks 5 meters east. That is from A to B. They say that this is what? 5 meters, because he's going east. And then walks 7 meters west, which is from B to C. So they are saying that from here, going to C here. So the distance here, they are saying is what? 7 meters. The process takes 20 seconds. That is the total time taken from him to move from A to B and from B to C. Now they're saying use a vector diagram and represent the two displacements of the man from A to B and from B to C. Label all the vectors clearly and write down the displacement next to the vectors. Use a scale of 1 centimeter representing 1 meter for your diagram. So the question there wants us to draw a vector diagram. So the vector diagram is for the passing of that impatient what businessman. So how do we draw a vector diagram? We simply actually start drawing our first vector. So our first vector, it's actually from A to B, which is just what? That is 5 meters. And then our second vector starts from the head of our what? Of our first vector, going to the direction that was mentioned. That is actually what? 7 meters going to the what? To the east, to the west. So this was for 7 meters. So we need to actually get to represent this in terms of a scaled diagram. So let us draw that vector diagram onto scale. So they gave us the scale to say 1 centimeter should represent what? 1 meter. So what you are supposed to just have came and did there, you are supposed to say, I'm starting here. So you were supposed to say, I'm starting from here. And then they told you that you are drawing 1 centimeter is representing 1 meter. So 5 meters would be equal to what? To 5 centimeters. So this is my first vector. And then my second vector would actually get to start from this head of that what? It will start from that head of my vector going 7 centimeters west. So 7 centimeters will represent 7 meters. So that would be what? 7 centimeters. So that is how you would have drawn your what? Your vector diagram there. Where you know that this one would actually be 5 centimeters and this one would be 7 centimeters. I'm sure you saw how I did it. And then up until there, and then these ones they are starting from the same, and then from there to there, that's 7 centimeters. So that is all that they wanted you to do there. That is how you draw a vector diagram. And then you just simply come, you actually get to label to say this is point A, and then this is point B, and then this is point C. So this one will be point C. After labeling like that, where you say that your scale is saying that 1 centimeter is equal to 1 meter. So you just need to label that what is your scale, and then make sure that you label everything that is given there. And then that becomes your vector diagram. Now, let's go to the following question. They are now saying that what is the businessman's change in position at C relative to A? You can see that C relative to A here. This is where we now get to use our scaled diagram to say that my change in position from here to there, I'm just 2 centimeters west from A to C. So you would have just came here and say that 2 centimeters west. That is the change in position. Initially, his initial position, this is initial position. His final position, yes, he went to B, but he later came back to C. His final position is C. This is where he is now. That is his final position. So his final position, it's actually what? It's 2 centimeters to the west, because we know that the distance from here to there, it's 2 centimeters. And then the 2 centimeters represents how many meters? You said that 1 centimeter is equal to 1 meter. So 2 centimeters would be equal to 2 meters. So your final answer would be 2 meters what? West. So that was the change in position there, because we know that these 2 centimeters will represent what? 2 meters. Now let's go to what? To calculate the total distance that the man covers. Before I do that, at some point in time, someone would have just came and said, my resultant position would be equal to my first vector. Let me say that my first vector, let's use x, because we know that we are looking for distance. So my first vector, which will be x1, my second vector, x2, would give me my resultant. So my first vector is a positive 5 when we define east to be positive. And then my second vector, it's a negative what? It's a negative 7. So this was going to be equal to what? This was going to be equal to a negative 2. This was going to be a negative 2. And negative 2 at meters. So negative means west. So you would have just ended up determining your position as what? 2 meters to the west. Either way, we are defining our change in position from here to there. Yes, you went positive 5 meters going that side and the negative 7 meters going that side. If we say east is positive, so you end at negative 2 meters away from A, which is 2 meters west of A. Now the total distance. The total distance is different from displacement because now we are looking at the total length covered. We are now looking at the what? At the total length covered. What is the total length that was covered? The total length what? Covered. So the total length covered was what? 5 meters plus 7 meters. So the total distance the main covers is equals to what? 5 meters plus 7 meters, which is equals to what? To 12 meters. That was the total distance. And distance does not have direction. It is just having its magnitude. Now explain why the value calculated in question 4.2 differs from the one calculated in 4.3. 4.2 was saying 2 meters west, and this one is saying 12 meters. The difference is this is the total length covered. This is the total length. And then this one is just a straight line length between 2 points. Straight would actually get to what? Say straight line length. Straight line length. So this is the straight line length that would be in between position A and C. But this is the total length. So here, when they said explain the difference between the two, you would have just came and say that you would say this is 4.4. You would say in 4.2, we were calculating the change in position. Change in position. Which is a straight line length, which is a straight line length between the initial position and the final position. And then you get to say while, let me just get to move this up a bit so that we can have space. While in 4.3, while in 4.3, we were calculating the total length covered, irregardless of direction. So don't mind my long explanation. I actually want you to actually get to understand what we are saying. So we are saying that in 4.2, we were calculating the change in position, which is simply the straight line distance or straight line length between the initial position and the final position. While in 4.3, we were calculating the total length covered irregardless of direction, the whole total length. So someone would have said that 4.2 is just straight line length, while 4.3 is the whole total length. It's still correct. Now let's go to 4.5. So 4.5 is saying define the term velocity. Define the term velocity. Now 4.5 would come and say velocity is the rate of change of displacement. Rate of change of displacement, or else total displacement per unit time. The total displacement per unit time. And then now here they're saying calculate the mains average velocity. So the total displacement per unit time, that becomes the average velocity. So here we're going to say average velocity, which we usually denote by VF, can be given by the total displacement covered per unit time, which is the total straight line length in between two positions. So this total straight line length was just equal to what? 2 meters west divided by what? 20 seconds. They told us that the whole motion took 20 seconds. So if you did that, it would be 1 over 10. That is just what? 0.1 meters per second to the west. So our answer there was just supposed to be what? It was just supposed to be 0.1 meters per second west. Don't forget to mention the direction, because we know that our velocity has got both magnitude and direction, just like our displacement would be having. So there we can actually get to note that our average velocity was now going to be equal to what? 0.1 meters per second. You just get to say 2 meters west, which is the total change in displacement, divided by the 20 seconds that they took there. So it will be 0.1 meters per second west. Now let's go to our last and final question that I have here, which is question number 5. So this was question number 5, and let's get to read what question number 5 was saying. So question number 5 was saying the reaction between magnesium and dilute hydrochloric acid is represented by the balanced equation below. This is the balanced equation, where 1 mole of magnesium is reacting with 2 moles of hydrochloric acid to form magnesium chloride plus hydrogen gas in terms of its mole ratio. Now, during an experiment, 1.5 grams of magnesium, which is this one, reacts with excess dilute hydrochloric acid, which is it reacts with excess dilute hydrochloric acid to produce hydrogen gas at standard temperature and pressure. Now they're saying calculate the mass in grams of hydrogen gas. So we want the mass of hydrogen gas. The mass of hydrogen gas. How do we find the mass of hydrogen gas? We can use the number of moles is equals to mass over the molar mass of this hydrogen gas. But now we can only determine the molar mass from atomic mass. What about the number of moles? Because we want mass, mass would be equal to number of moles times the molar mass of that hydrogen gas. How are we going to determine this number of moles? We are not given any information to do with hydrogen, but we are given the information to do with what? With magnesium. So we need to find the mole ratio in terms of this reaction of how much magnesium is used in terms of moles to produce how much of hydrogen in terms of moles. So you can see it's 1:1, because they told us that the reaction between magnesium and dilute hydrochloric acid is represented by a balanced equation. Once you have a balanced equation, you can be able to relate the mole ratio there. So I need to determine the number of moles of what? Of magnesium. And then those number of moles of magnesium used, they are equivalent to the number of moles of what? Of the hydrogen that is being produced. Because this is what the mole ratio is saying, 1:1. So my number of moles of magnesium, how am I going to determine them? I'm going to use the mass that is given divided by the molar mass of that magnesium. So just allow me to create space so that I can do what I've just explained there. And then that is how we determine the what? The mass of our hydrogen gas that is produced. So that is 5.11. So for our 5.11, I would have just came here and said 5.11. And then I would come and say number of moles of magnesium that is produced is equal to 1.5 grams divided by the atomic mass of magnesium. What is the atomic mass of magnesium? This one is not more common. So I actually brought a periodic table so that we can use in terms of referencing to calculate our atomic mass of magnesium. So this is the atomic mass of magnesium, which is just 24. So that is the one that we were just supposed to what? To use 24. So the atomic mass for magnesium is 24. So its molar mass, the molar mass of magnesium becomes equal to what? 24 grams per what? Per mole of that element. So we are going to use that. So let's return to our question and let's be able to use that. So now, since we now know the molar mass of magnesium, let's actually get to calculate. So divided by 24 grams per what? Per unit mole. So I'm going to find the number of moles there. So I'm going to say 1.5 divided by 24. If I say 1.5 divided by 24, I was going to get 0.06. I was going to get 0.0625. 0.0625 moles. Just cross check that answer. So those are the number of moles of magnesium. So I know that the number of moles of magnesium that I used are in ratio to the number of moles of hydrogen that are going to be produced in a ratio which is 1:1. So I know that the number of moles of hydrogen that are going to be produced are also equal to what? 0.0625 moles in terms of that ratio. So the mass of hydrogen that is going to be produced is just simply equal to the number of moles times the molar mass of that hydrogen gas. We know that the atomic mass of hydrogen is just 1 gram. And then, so the molar mass of hydrogen, since it's H2, its molar mass here, the molar mass of hydrogen would be equal to 2. So we are just going to say 0.0625 times 2. And then we can get what? Our mass in grams. We can get our mass in grams there. So here our mass was just going to be equal to what? 0.125 grams. So if we had used 1.5 grams of magnesium, if this was the mass of magnesium that reacted, we're going to produce 0.125 grams of what? Of hydrogen. That was the mass of hydrogen. Now let's hear the following questions. So allow me to move so that we can see the next questions. The next question is now saying, calculate the volume in decimeter cubed of hydrogen gas produced at STP. Now I would actually get to say that this is 5.12. 5.12. We know that 1 mole of any gas, 1 mole of any gas at STP, let me say at STP, is equivalent to 22.4 decimeter cubed. Now, I've got the number of moles of hydrogen gas is equal to 0.0625 moles. Those are the number of moles that are being produced. How much volume will be occupied by these number of moles of this gas? So I would actually get to say that the volume of what? Of my hydrogen gas that is going to be produced is equal to 0.0625 moles times the volume that is occupied per each mole. So this one would be decimeter cubed per each mole, so that we can cancel out these ones. So you would actually get to see that the volume there, if you say 0.0625 times 22.4 decimeter cubed, you are just supposed to find 1.4 decimeter cubed of hydrogen produced. Some, they like to use this equation which says N is equals to either, let me get to say that N is equal to the volume of the gas divided by the molar volume at what? At STP. So that if I know the number of moles, I would say that the volume of the what? Of the gas is simply equal to the number of moles times that molar volume at STP. And I know the volume at STP, so I just get to say 0.625 moles times the volume at STP. It's still the same thing. Either you used this formula, which becomes easier if you actually get to go to your information sheet, these formulas they are given, or else you try to reason with the information that you are given by knowing that at STP, 1 mole of gas occupies 22.4 decimeter cubed. So you would have either done it in this way or else you would have just followed this format. Let's hear what the next question says. So the next question was now saying that calculate the mass in grams of magnesium chloride produced. Now we need to look at magnesium chloride. And we now want to calculate also the what? The mass in grams. So we also use the what? We also use the mole ratio of the given information of what? Of magnesium. We're given the information to do with magnesium. So magnesium, we react 1 mole of magnesium to actually get to produce what? 1 mole of magnesium chloride. So they are still related as to 1:1. So I can know the number of moles of magnesium chloride from the number of moles of what? Of magnesium. So the number of moles of magnesium chloride were, of magnesium were 0.0625 moles. So these are the same number of moles of magnesium chloride, which is 0.0625. Just like we did for hydrogen. And then I take this number of moles to actually get to calculate my mass by using the molecular mass of this. Just like we did for what? For hydrogen. So let's go and see how we would have also done for 5.13. So we are still continuing here. So maybe I would also have came just below there and said 5.13. I would say that the number of moles of magnesium chloride that is produced is equivalent to the number of moles of what? Of magnesium that is reacting, because they have a molar ratio of 1:1. So this would be equal to 0.0625 moles. And then I know that the number of moles of magnesium chloride, I can actually calculate it by using the mass of magnesium chloride divided by the molar mass of that magnesium chloride. So that if I want this, I can use this and that. So that my mass that I'm looking for the produced magnesium chloride would be equal to 0.0625 times the molar mass. So the molar mass, where we said magnesium there, we actually saw that magnesium has got an atomic mass of 24, plus for chlorine, we know that chlorine is 35.5. And then if we multiply by 2. So let me just actually get to show you where I am actually taking those values so that we can be able to calculate the molecular mass of what? Of magnesium chloride together there. Because some, they'll be asking themselves, where are you taking those values? I can't see them. Where are you taking those what? Those values. So this is where we have. So let's actually get to what? To rub here. So we are saying that for magnesium we have got 24. What about if we now want to actually get to say what? What about if we want the molar mass for what? For magnesium chloride. So I'm just trying to actually get to remove this so that at least we can actually get to see where we are. So I can actually get to come and say the molar mass for magnesium chloride is equal to 24 plus for chlorine, I have got 2 of them. What is the molar mass for chlorine? It's 35.5. So you would come and say 35.5. So you would say 24 plus 71, because if you say 2 times 35.5, it will give you 71. So this one was going to be equal to 95. That is the molar mass of magnesium chloride. That is the one that we are going to use. Let's go back to our question and get to see how we would have used that molar mass. So our question was here. So here, this is where we would have used what? 95. So that one was going to be gram per mole, since these ones are moles. And then at the end of the day, we would find grams. So if you say 0.0625 times 95, you are going to get the mass of what? 5.95 grams. So the mass there was just going to be 5.95 grams. So it's 5.95 grams. So that is how you would have calculated the mass of magnesium chloride. Now let's go back to our question. So our question is now saying, calculate the number of chlorine atoms present in the magnesium chloride. So the chlorine atoms that are present here, we know the number of moles, and we know that in 1 mole we have got how many atoms? We have got 6.022 times 10 to the power 23. So now we get to look at the atomic ratio here. So here we've got 1 atom for what? For magnesium, and 2 for chlorine. So we want to look for the chlorine atoms. So since there are 2 chlorines in magnesium chloride, and we know that in 1 mole of chlorine we would be having what? 6.022 times 10 to the power 23. But now, what is the number of moles of magnesium chloride? We know that in 1 mole of this magnesium chloride, we would be having 6.022 times 10 to the power 3 atoms. So using this atomic ratio times the number of atoms per each mole times the number of moles of magnesium chloride, we can calculate the total number of chlorine atoms. So the total number of chlorine atoms we're just going to be given by that number. So let's get to see how we would have done it. So just allow me to rub some of the things like this so that I can use this space. So at some point in time, I would simply come and say 5.14. I would say that number of what? Number of chlorine atoms. So this would be number of chlorine atoms can be simply equal to what? The number of moles of what? Of my compound, which is magnesium chloride, times the atomic ratio. So I would say the atomic ratio of my chlorine in the what? In the magnesium chloride. And then times the Avogadro's constant. Because we know that at some point in time, number of moles can be given by the number of atoms or particles or entities divided by the Avogadro's constant. So when you now want to find n, you will simply say n times what? Na. But now this is when you just know this value exactly. But now we also need to know an atom which is within a compound. So we need its atomic ratio here in this compound, so that we can multiply it with the number of moles, then by the Avogadro's constant. So here, at the end of the day, I would have just came to say that, okay, fine. From that, I would have just came and said the number of moles of magnesium chloride, we determined them to be 0.0625 moles times atomic ratio there for chlorine, it's 2, times our Avogadro's constant, it's 6.022 times 10 to the power 23 atoms in 1 mole. That is atoms in what? In 1 mole. If that is the case, I would also come and remove this. These, they will cancel out. So at the end of the day, I'll be left with the total number of what? Of atoms. So I need to multiply this number throughout. So this one is what? Is our Avogadro's constant. So if I use my calculator in multiplying that, at the end of the day, I would find 7.533 23 times 10 to the power 23 atoms. So this is a rounded off number. So these are the number of atoms of what? Of chlorine atoms in magnesium chloride using that equation that we have. Now let's hear what the other questions were saying. So the other questions, they were saying that the empirical formula of a certain compound is to be determined on an analysis. So this question is different from what we're doing. Let me just get to rub off everything so that our workplace can actually be neat enough for us to actually get to do some of these things. So I would actually get to wrap off here. I just want to create space, guys, and also decongest my workplace because I can see that I've actually congested my workplace here. So explaining some of the things, it might be a bit difficult, or sometimes someone might not be able to follow neatly. So let me just try. I want to create enough space for me to answer that question. So I would answer it using this space below here. That's why I'm actually erasing this. So now, with that space that I have, let's look into the question and hear what it is saying. So the question is saying, the empirical formula of a certain compound is to be determined on analysis of a sample of the compound. It was found to contain 71.65% of chlorine, 24.27% of carbon, 4.07% of hydrogen. Define the empirical formula. So the empirical formula is the simplest whole number ratio of atoms in a compound. You would say that this is the simplest whole number ratio of atoms in a compound. So this is the simplest atomic whole number ratio in a compound. The simplest whole number ratio of atoms in a compound. Meaning to say that at some point in time, you can find our empirical formula being CHO. It simply means that our compound is made of carbon, hydrogen, and oxygen in simplest ratio of 1:1:1. But that might not actually determines our actual molecular formula. It is just giving us an idea of how this compound is actually made of, how these atoms are actually combined to form that compound. It's an idea. So this is just the simplest whole number what ratio. Now they're saying determine the empirical formula of the compound and show all calculations. I usually advise to say that for a question like this, let's use a table, good people. It will be easier for us to follow and even for us to determine our empirical formula. So I will try to draw a table where on my table I'll need to list down the elements that I'm going to have in my compound. So I will say elements. So I need the elements that I have on my compound. So I would also get to take a basis, which is to say, let me get to say I would assume a certain mass of that compound. So since this is given in percentage, I would assume just 100 grams of what? Of my compound. To say that this is my total mass of the compound that I have. And then the elements that I have chlorine. And then after chlorine, I'm going to have what? I've got carbon. After carbon, I'm going to have hydrogen. So these are the elements that I have. And then I need to determine the mass of each, the mass composition of each in our compound. So if I've got a percentage composition of chlorine in my compound, I can be able to calculate its mass composition to say that what is 71.6% of this compound that is having 100 grams equal to. So you would see that this will be equivalent to what? 71.65 grams. So the reason why I chose 100 grams is so that I can actually have these totals being equal to 100. So that I can actually get to just take simply this be equal to that mass. So 71.65% would equivalent to what? To 71.65 grams in terms of its mass composition. So carbon would be equal to what? 24.27 grams. And then hydrogen would be 4.07 grams. And then now I want to determine the number of moles of each, in this compound. So I will say mass over the what? Molecular mass. So I will use baby M over the big M. So let me just get to represent the big M with that black color, so that at least it will differentiate what I'm using there. So my number of moles for what? For chlorine would be equal to this mass 71.65 divided by the atomic mass of chlorine. What is the atomic mass of chlorine? We say the atomic mass of chlorine is 35.5 grams. We say that it's 35.5 grams. That is what we found from our periodic table. So that is what I'm going to use there, 35.5 grams. So 71.65 divided by 35.5, what would be the number of moles there? It would be 2.02 after rounding off moles. And then here, the number of moles would be equal to 24.27 divided by the atomic mass of carbon. We know that the atomic mass of carbon is just 12 grams. So here it will be divided by 12. So this one is 12 grams per each mole, 35 grams per each mole. So that if I divide by that per each mole, it will give me the number of moles. So if I say 24.27 divided by 12, I was also going to get 2.02 moles. And then if I say the number of moles of hydrogen would be 4.07 divided by the atomic mass for hydrogen, we know that it's 1. That would be 1 gram per each mole of hydrogen. So I would be having what? 1 here. So that the total here would actually come to be 4.07. Now, I now need to calculate my simplest whole number ratio. I need to determine my simplest whole number what? Ratio there. So I would have just came, let me erase these ones so that I can actually get to write what I want to write there. I now need to determine my simplest whole number ratio. How do I actually get to determine my simplest whole number ratio in terms of moles? I would find the least or else the smallest value between this number of moles. So the smallest value is this one, which is the same as this one. So I would divide this by that. So it would be 2.02 divided by 2.02. This is going to give me 1. And then if I divide 2.02 divided by the same value, it will also give me 1. And then if I divide 4.07 divided by 2.02, this was also going to give me what? This was going to give me 2. So the simplest whole number ratio there, it's 1 is to 1 is to 2. So I've got chlorine being 1, carbon being 1, and then hydrogen being 2. So my empirical formula would actually get to come and say what? At some point in time, I would have what? I would have maybe had, I would take H, C, and then Cl, then this one would be 2. Or else, I would have just came in, I would have just written it in a way to say C, it would be H2CCl, or else I can just come and say ClCH2, because I'm just looking for a what? For the simplest whole number ratio there. The simplest whole number, what? We said this is the simplest whole number of atoms in a what? In a compound. So I would actually have to say that, however, though I know that when it comes to uh, reacting these or else making compounds of this, my carbon and my hydrogen would actually get to what? To come to combine first. So I would be having my what? So I would be having my carbon. And then this would actually get to bond with hydrogen. So this one would be CH2. And then later on, I would have a chlorine atom bonding to this carbon hydrogen what? Molecule, or else, yes, this carbon hydrogen compound. So that was going to be your what? Your empirical formula. So this one was going to be your empirical formula. So after determining your simplest what? Whole number ratio, you now need to come and determine how these compound or else how these atoms actually react with each other. You know that carbon reacts with hydrogen. You first get to say carbon, hydrogen, hydrogen. And then after having carbon, hydrogen, hydrogen, that's when you now have what? That Cl. So it will be CH2Cl. That is how you get to react this. So at the end of the day, that becomes your what? Your empirical formula. So after saying that, that was what? That was our final question, which said determine the empirical formula of the compound and show all working. So that was our question paper, good people. Thank you for being together. Let's continue to shine, and also let's continue to win and shine light upon others. So just get to share, also invite a friend and a friend and a friend. So at the end of the day, continue actually bringing in these question papers, your request, as well as questions that you want us to tackle specifically. We would actually get to attend to them. So let's meet once again next time. So guys, continue watching and revising and preparing for your exams. Just leave a comment, a like, or else your request that you want us to do. We would actually get to attend to that.